Okay, so now we go with the handout number 1 for electronic. Okay, last 3 meetings, we're talking about DC fundamental. That's the basic for DC. And now, from now on, very important thing for technician electronics, okay, device. The first one will be learning. They will be a diode, okay? And now this is a remind, make sure you must be understand, okay, for this thing here, like you see the sideway, and you have to know which one will be V peak or V peak to peak, which one will be a period of frequency, okay? This is what we call a time domain. You understand the time domain, that means the signal vary with the time. You can see this is the time right here. Okay, so that's the time domain. And the positive, we call a positive alternation, and also the negative alternation. Okay, and try to make sure you know the definition. What is the cycle? One complete occurrence of a repeating way, periodic signal, such as one positive, one negative alternation of the sideway. That's the definition for a cycle. And the definition for frequency is the number of the cycle of a signal occur in 1 second. Okay, period. The time distance between two similar positions on a periodic way. Then now, if you're looking on this one here, they're talking about wavelength. Okay, so wavelength is thing like the period, but they say the distance traveled by electromagnetic wave radio during one period. The thing is you have to understand basically the definition. Okay, and the wavelength can be calculated by the formula. That formula to doing calculation for wavelength. We don't care now until we're learning on the radio frequency. Okay, and also you must be knowing this will be displayed for the sine wave on the oscilloscope. Okay, and you already know from the top here, okay, to the bottom here, that means voltage peak to peak. From the 0 here, go to the top or go to the bottom here, will be V peak. And from this side point here, go to this one here, one cycle, one period. So if you're looking into the thing they already telling you, okay? Now, on this oscilloscope, they say 1 volt per division. This is a volt division. 1, 2, 3, 4, 5, 6, 7, 8. And 1 volt per division means what? At one division you get 1 volt. So V peak you can count 1, 2, 3. That's what they call 3 volt right here. Okay, peak to peak means of the bottom here go into the top. You get 6 volt. Okay, and if you want VIMS, then you take 0.707 times V peak. Okay, we don't care much about V average. That's just a formula. Okay, and also for the period, that means the time division. Okay, that means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You get total will be 10 division. And they say each division will be 1 millisecond. So period will be from here. You can count 1, 2, 3, 4, 5, 6. This a half, this and a half. That means 7. 7 division, you get 1 millisecond per division. You get 7 milliseconds. An oscilloscope cannot measure the frequency directly. So you want the frequency, you must be using the formula. F equals 1 over T. And that's why they given you 142.8 hertz. Okay? Try to understand when you're doing on the lab, you're able to do it. If you guys get a question or anything confusing, just let me know. Otherwise, I keep moving. Okay, so just a display for you, okay? I just given you a short explanation. You can see on the bottom here, okay? That's what we call a generator. And on the top, that's the oscilloscope. So the generator will be giving you the sine wave, okay? And they connect you into the oscilloscope so they can display the sine wave here, they can measure it, okay? Oscilloscope just a measure device. They cannot change anything. You want more voltage, you get a more frequency or whatever. You cannot using, doing with the oscilloscope that coming out from generator, okay? That's the key point. Oscilloscope just a measure device. Whatever coming out generator, they measure it, okay? But you want more voltage peak to peak or more frequency, you cannot changing by an oscilloscope. You must be changing in the generator. Now, this is going to the one for today. Diode. Okay, this is giving you the basic physical on the diode. That means they can using silicon or germanium to make the diode. So basically, one side they contain negative and another side contain positive. That's what they call a P time or N time. Okay, P time they contain positive. N time they contain electron. Okay, so electron will moving, then the current will be flowing. Okay. Also, you understand electron moving will be moving this way. Okay. However, we're talking about conventional current. That means the current will be flowing from positive to the negative. Okay, so we don't care about much physical, okay, for the diode. Now we care about this is a symbol. Symbol for the diode, every time you see this symbol, then you must know this is we call a diode. Okay, one side A anode and the other side will be C, will be a cathode. Okay, so the voltage from A to C here, that means they call a VD. What that mean? VD, that means the diode voltage. VD means the voltage from A to C. So they will be VA to C. And also, by basic definition, VA minus VC. get the basic voltage across the diode. We already telling you right here. VD equals VA minus VC. That means the voltage across the diode. Okay? Diode normally permit the electron current flowing only one direction. Okay? That means the current will be only flowing from A to C. Okay? Cannot flowing from C to A. That's only one direction. So, for this slide here, what I want you to understand is when you're looking into the symbol and you know that is we call a diode, okay? And also the voltage across the diode VD must be equal VA minus VC. A means anode and C a cathode. Okay? Now, when you're working with the diode, and the diode, they can be on or off, okay? Either they on or they will be off. On means conducting. Off means open. Okay, now, what that means when they say ideal diode? Okay, ideal diode means the voltage across diode here, VD equal 0 volt. Okay, that means no voltage.
No leak.
And the diode, only thing that they can be off or they can be on. This what they are. What that mean? When they off, look like they open. No current flow.
And that's when the diode is reverse biased. So there's a positive voltage at the cathode.
Right. They said reverse bias. That means diode will be off or not conducting. Look like the switch. They open. So that's why no current flowing from A to C. That will be A here.
Mr. Pham, question.
Yeah.
Can there be the slightest small leakage from A to C?
Only in a real diode, not an ideal diode.
Right. In general, there is a slight leakage, correct?
I'm not quite follow.
Well, if there's supposed to be 0 volts, ideal understanding.
Yeah, ideal. That means, okay, when you conduct, they just like the wire, no resistance. However, if not ideal, then they get a resistance, a little resistance. Now I say if they off, that means reverse bias. Look like they open. No current flowing from A to C. And this the forward bias, could mean the diode on or conducting. And the current able to flowing from A to C. If you're reading, they say a diode on a forward bias For the ideal diode, VD will be 0. For reverse bias, they say diode will be off. That looks like the open circuit from A to C. No current can be flowing. And the resistance will be infinity ohm between A and C. That's only thing I want you to know. For the next page, you can see the difference between the ideal diode and a practical diode. They just get a difference on the VD. Okay, practical diode VD can be equal 0.7 volt or 0.3 volt.
Hey, Mr.
So
Sam? Oh,
Go
go
ahead.
ahead, Joseph.
yeah, I was just going to ask. So that's for that 0.7 for silicon or 0.3 or 0.4 for germanium come, since the ideal diode is typically 0, but in the real world, we know that we don't really get 0. We get a little bit of source. So that's where the 0.7 comes from.
Yeah, that means when we go to the next slide, then
Right,
we're
right.
working with the real diode, not ideal.
Mhm.
However, otherwise, they give it to you and they say that the ideal diode, you don't know what's going on.
And the 0.7 is on the anode side, right?
Yeah, that's the voltage across the diode.
Okay, yeah. All right. I'm sorry. Yeah, go ahead. Next person. Thank you.
Now, second, approximation. That means practical diode. And VD for silicon diode. That means diode made by silicon. VD 0.7 volt. Or if they make by germanium, and VD 0.3 volt. Okay?
Hey, Mr. Pam, I don't want to beat this up. I've seen some books they have for germanium, they have 0.4. So 0.3 or 0.4, correct?
Yeah. But I know for sure they will be 0.3.
Yeah. I'm just saying I've seen
That's
textbooks.
okay.
Yeah.
Not big deal. But
All right.
normally they not deal with the germanium. They deal with the silicon.
And it's temperature dependent anyway.
Okay, so now, same thing. They can be on or they can be off. This they will be off. That's why you see they open right here. No current flow from A to C. And on the other thing here, they will be on. Okay? And now you can see they can get a 0.7 volt battery. And the current able to flowing from A to C. Okay, now I can explain to you a little more why 0.7. You see, like we draw the diode physical here. Okay. This is a P side, N side. Okay. This is a depletion region. Negative electron on this side here will be moving into the P side. Okay. Why they asking for 0.7? That only telling you at least 0.7 volt, that will be enough energy to electron moving. Okay, less than 0.7, electron not moving. That means the diode still open. Same thing happened for germanium, different type. They need 0.3. Okay, now looking to this circuitry here. You get a power supply 10 volt, resistor 1 kilo ohm, and a diode. So whenever you're looking into the circuitry with the diode, if you don't know the diode will be on or the diode will be off, you cannot solving the problem. Okay? So in the example number 1, can you tell me the diode on or off?
Diode on.
On.
On the region A. This side you can get almost 10 volt. Okay, this side you can get almost 10 volt here. This side you get a 0. So the voltage across the diode here, you want that have to be VD greater than or equal 0.7 volt, then they will be off. So you know difference between 10 and the 0 volt, they have to be greater than 0.7. Okay? Then the diode now will be on.
Hey, Mr. Pham, and another way of saying it would be that the anode side's got to be more positive for forward bias than the cathode side.
Same thing.
Yeah, right. Okay, got you.
Now, after you say, yeah. After you set the diode on, I don't want diode anymore here. You must be substitute the diode by 0.7 volt. Okay, so now I have to draw this thing. Positive, negative. Blood minus 0.
Quiet, Handler.
Okay, so forget this guy. You see that?
Mhm.
When you say diode on, then you must be substitute diode by the battery. You know which one positive, which one negative. And the value will be 0.7 volt. Okay. And now if they want to say, okay, what the voltage V out? What do you think the voltage V out supposed to be?
10 minus 0.7.
Come on.
Oh, I'm sorry. V out is 0.7.
When they asking V out only, that means the voltage from the V out to the route.
Right.
That means the voltage from here to here.
Wow. 0.7.
Okay. Now, that means you measure the voltage across the battery, 0.7 volt.
Mhm.
Then make sure you understand. When you measure the voltage across the battery, you get that battery voltage.
Correct.
You don't care where they connect you. For example, you take the DMM connecting to your car battery. Even that car battery connect into your circuitry inside the car. However, you measure you're supposed to get 12 volt, right? That just bring it up to you to make sure when you measure the voltage across the battery, you must get that battery voltage. Okay? So in this case, the answer will be 0.7 volt. And number one, we say diode on. That's what I told you. See the diode, you must know on or off. Otherwise, you cannot do anything. Okay, that's the first part. Any question on that?
So do we know the, okay, so could you go over how we know the diode is on?
Okay. The VD, that means the voltage across the diode, VD. If they greater than or equal 0.7 volt, then off. If they less 0.7 volt, they will be off. And now if you're looking on the circuitry, on the V out, you get 10 volt from power supply bias. And another side will be the route. Okay, so that means the VD across the diode must be greater than 0.7. That's why I say on.
Okay, and you can tell the way, if this is not a great way of thinking about it, please cut this off now, but I'm looking at this as like an arrow that is being blocked off by a line. Is that the way to think about it? So it cannot go past this point. Is that the way it's blocking the voltage?
What do you mean blocking the voltage?
Not blocking the voltage, but
The current.
the current. Yes.
Yeah, maybe I might suggest that the diode symbol shows the arrow is pointing in the direction that positive current can flow. And the line is the blockage when if there's a positive voltage applied at the cathode side, which is the line side.
The current must be flowing this way. From anode to cathode.
The conventional current.
They must be. That is the way. Conventional. Okay.
Hey, Mr. Pham, is it possible to put like the plus minus, for instance, like on the battery on the top, you got plus. So all the way over to the first resistor, you got plus, and then on the other side, you got minus. And
That
then,
depending on the diode. I said that's the A, right?
mhm,
That's a C. A
Right.
have to be positive.
no, okay, but what I'm saying, because of what that gentleman asked, for the purpose of trying to determine forward or reverse bias, you can put pluses and minuses around all the, say like resistors or whatever, and then you can look at it and see if the anode is more positive or more negative. I don't know if that makes sense, but it seemed like it works for me.
Okay, now if you see a next one, you can see the difference. Okay. However, what I'm saying is the current must be flowing from A to C.
Right.
Any voltage VD greater than equal 0.7 volt, then the diode look like the wire. They allow the current to flow. Otherwise, if less than 0.7 volt for germanium, for silicon diode, that means the diode off, they will be open. That's it.
Mhm.
So now, if they say they want to calculate the current, that means they want the current flow here. Okay, V over R. That means you get VR. if you get a point A
0, 1.
here, okay, I can put the point B here or A here, okay. VR mean we wanted across this register. I can say that will be VB minus VA. And that will be 10. Okay. Minus V out means 0.7.
17.
You get 3.9. Oh. And if you want to calculate I equal VR divide R. So they will be 9.3 volt divide 1K. When you divide voltage to the kilo ohm, automatically you can get milliamp. You don't have to change the unit.
Mr. Pham,
Yeah,
you wrote I equals VR over R. That it should be just I equals V over R, I think.
I think he was talking about the resistance voltage over R.
Oh, V sub R.
Yeah.
Oh, okay.
that's how do we calculate the current. 9.3. That's what I given you here.
Mr. Pham?
Right.
I'm wondering if it might be helpful if you had a graph of the current versus applied voltage for an ideal diode and a real diode to help people understand how the current varies with voltage.
That is when you're going down more, you can see relation between the voltage and the current. But for the calculation, you must be go this way. Otherwise, more confusing. Only thing what I said is when you're looking into the circuitry with the diode, if you don't know the diode on or off, you cannot do it. And if you see if they on, what else you have to do to solving the problem? That means you have to substitute the diode by the battery plus or minus 0.7 volt. If they off, that means the circuitry will be open for now. And if you want to know the relation between the voltage and the current going down on this lecture, we will get it. But don't try to go too much into that. We'll be confused. A lot of students. We try to make it simple as much as we can. I said, I given you this diode circuitry. You have to telling me diode on or off. That's the first step. If they on, what happened? If they off, what happened? And we can do the calculation for the voltage or for the current. Okay, now go to the next one. Okay, for the next one, putting diode on or off.
Diode off.
You understand 5 volt here. Okay, so VD equals 0 volt here. 0 minus 5. Minus 5 volt. Less than 0.7. Diode off. If you not agree with me, let me know.
Hey, Mr. Pham, for the, you said VD equals VA minus VC, right?
right? And you understand?
Okay, I get it now. So VA is the 0 and VC is the 5.
Right.
So the voltage across the diode is minus 5 volts.
Yeah, yeah.
How did you find the V out is 5?
You see the V bias 5 volt.
It looks like because the diode is reversed. Now the positive voltage is on the cathode, so it's reverse bias and it's an open circuit, so there's no current. So there's no voltage drop across our limit, right? So the battery voltage appears at V out because there's no current flowing in the circuit, right?
Yeah, don't go too much detail. You know that the V bias 5 volt. And on the side V out, you're supposed to be 5 or a little less, but it's not, you know, be 0. So you get a 0, one side 5 volt, the other side you're doing calculate the VD, you get a minus 5 volt. And a minus 5 volt will be less than 0.7 volt, diode will be up.
The voltage drop is in like microvolts.
Who cares? Now I
Well,
say they up.
Yeah, it just goes along with what you're saying, Mr. Finn.
So if you not agree with me, let me know. I say the diode up.
Mr. Pham,
Yeah.
I'm a little confused. So when the diode is off, the voltage is automatically negative?
Now, what do you mean a negative? You know the VD first.
Yeah, the V bias is 5, and then you write down over there -5, and the diode is off.
Yeah. Okay, now I need to ask you a few things.
Hey, Mr. Pham, while you're doing that, the answer, or hopefully to answer a question, like I was saying before, on your V bias, you have pluses and minuses there. So maybe if you put pluses and minuses around the resistors and pluses and minuses around the diode, you know, have pluses and minuses everywhere, maybe they could see where those pluses and minuses are at.
That's okay. Now I asking you. Okay, tell me for this diode on or off.
On,
Ha,
on, because 0 minus 2, we have flow from 0 to -2.
Okay. In order to know
Yeah.
diode on or off,
Is that -2 or +2?
just a minute. Okay. If you want the diode on or off, you need to get the VD, right?
Right.
VD here will be VA minus VC,
Mhm.
and that will be VA 0 volt minus to minus, right? And they will be equal 2 volt, correct?
Right.
And that will be greater than 0.7 volt, and the answer will be on. Is it okay?
Yes.
Yeah.
Okay.
-2. And 0 is more positive than -2.
Okay, on up.
Off.
Off.
Yeah, so, because the cathode is more positive than the anode.
So you can
Right.
do in calculation. Okay, they will be 0 -2. Right?
Right.
Less than. So they will be up.
Will we ever encounter negative voltage in the field?
Depend on, when you get a difference greater than 0.7, you say on. That's it.
Okay.
And when they on, what I telling you, take the diode out, substitute by the battery. That means now you can get the battery, okay? Positive here, negative here. This is positive, this negative, and the value will be 0.7 volt. How do I know positive? The thing is depend on this is the anode here. So that's why you can get positive. And the other side will be negative. And when you say the diode off, only thing you need to know is they will be look like open. A here, C here, no current flow. That's only simple thing. Okay, so now on the second problem here, okay, we say we know for sure the diode will be up right here. They will be up. Okay, and they opt now. You can see, look like open. And if you want to know V out, what V out equal?
5 volt.
5 volt.
5 volt, right? The thing is when you get the open circuitry, the current I flow here will be equal, right? Current cannot flow in the open circuitry. They must be in the closed circuit. Okay, so V out will be equal 5 volt.
Em đi sẵn đồ đi ha. Bác gọi em sao?
Hey, Mr. Pham, so it's almost like you ignore the resistor. It's almost like
The resistance between anode cathode will be infinity or open. No current flow. Okay, and now they want to calculate the current. And now you understand the open circuitry. I will be equal to 0. And finally, they want to know the voltage here. VR. You understand VR will be I times R. I equal 0. That will be telling you VR equal 0. That's why you get a 5 volt on this side. They drop nothing. They will still get 5 volt here.
Mr. Pan,
Go ahead.
first, how did you know V out is something great like 5 volt? Maybe it was minus 5 volt. How did you find how much is V out? Then you result that it is off. V out maybe minus 2 volts. How much was that?
How come you say minus 2? Where you get minus 2?
I don't know.
You get a power supply 5 volt there. How come you say minus 2 or minus 3? Where you get that?
We don't know anything about V out.
Don't know, but you know 5 volt power supply here. How come you say you don't know?
Because there is a resistance between power supply and V out, and it may change something.
Well, you change it, that's different story. But you're working on the circuitry. I given you 5, you have to go with 5. You want to change to anything you want, that's for your guy, not for the lecture here.
I have a simulation, Mr. Fan, if you want to show them.
I think he's just asking, how come you get 5? So kind of explain that there's no current in the circuit, and that's why V out is 5. I think that's the answer to his question.
Because you're starting with 5.
Right, and if the current is, I mean, the diode is reverse biased, so it's an open circuit, so there's no current flowing. The voltage drop across the resistor would normally be I times R, but I is 0, so there's no voltage drop across the resistor. So the input voltage or the output voltage is equal to the input voltage because there's no current flowing in the circuit because the diode is reverse biased. There's a positive voltage on the cathode, so it's an open circuit.
Right.
Also, I think the voltage remains the same always, no, from A to B or A to C. So if it starts from 5, it will end at 5. That's what he's trying to say. It will be 5.
Yes.
I believe 5 is just an example, right? This is the example.
It's part of this problem.
So basically anywhere on the circuit, if you measured the voltage until that first empty circle, it would be 5 volts just because there's an open before the ground.
Yeah,
yes.
Diode open.
So in other words, the voltage remains the same.
The next slide whenever we have an actual complete circuit.
Okay, for this circuitry, you cannot say you can get VR equal minus 5, minus 2. How come? If you want, you must be change the battery. Okay.
I think what he's asking is that when VD is equal to 0 minus 5, it's supposed to be negative 5 because you're subtracting 0 to a negative. That's what he's asking. And then why is it that 5 volts on that slide?
Okay, why is the 5 volt in here? VL, right?
Yes, and he's asking if it's why is it not negative? Because when you
Oh.
you do the
Not
calculation for
negative.
VD,
Okay, I understand. I'm talking about negative. That means you have to calculate the VD. V from A to C. That means A will be 0. Minus 5. That minus 5 volt. So that will be less than 0.7. So that's why I say the diode will be off. That's just a proof for the diode to be off. But VL will be 5 volt.
Can you close windows?
I don't have any.
Kitchen?
It's closed. Must just be a cold night. I'm gonna turn the heat on.
No.
Richard, mute your mic.
Put on, sir.
Okay. Now for this problem here, can you do for me? I given to you number 1 asking diode on or off, and I want to calculate the current I. That means the current will be flowing this way.
What? Yeah.
It is off.
It's off.
Okay. The diode will be off. If you want to do it, you need to say this is A, this will be C. Okay. Then VD, VA minus VC, and you get 5 minus 8, you get minus 3. Okay, less than 0.7, they will be off. And now you calculate the current I. Okay, again, when you say they off, you have to draw this way. Here, open. Take that guy out. What current I equal?
0.
Perfect. Equal 0 amp. I think an open circuitry. Current cannot flow it.
Could you go over the first part of that one more time, please?
You mean the first part?
Yes, the VD equals VA minus VC equals 5. Could you go over that real quick?
That's what I say, VD. Oh, you need to calculate the VD. VD, if I say A and C, then they must equal VA minus VC. VA will be connected to 5 volt, and VC connect to 8 volt. So you get 5 minus 8, you get minus 3.
Okay, thank you.
And less than 0.7 volt, so that's why you say diode off.
Got it.
Okay, no problem. And then when they asking for the current, so the circuitry will be open, then the current equals 0. Go to number 4. And also make sure you know that will be A here, VC here, okay? VD, VA minus VC, okay? They will be 0, minus to minus 100. That equals 100 volt. That's how do I calculate. So, diode on or off? On.
On.
Diode off. Okay. The thing is 100 volt greater than 0.7. So they will be off.
Should be off.
Is that on or off?
It will be on.
You get don't see, I say, I right now on.
The forward bias.
Right.
Should be off.
The voltage is greater than 0.7.
Got that. Outside? You never get off. Simon, don't forget we need rice.
Okay, you done? Ready?
It's over here. The first one. Yeah, where we put the trash bag.
Ready.
Ready, right? Yeah, if you're not, you know, you're looking into the website.
I know.
Okay, folks need to mute their mics.
Even if it's
They need to mute their
$100.
mic. They're talking about their hamburger helper.
I feel like it's gonna hit 50,000. Dude.
Okay, now this for your guys reading. Okay. You can see that from the left volt. Diode normally permit electron current flowing on one direction. Okay, so you can see on one side here, positive, negative here. So when the electron moving, and that they will be on. And also given you this is a symbol for the diode. Okay, that's just for reading. Okay, I don't care much about that thing for you guys. Okay, now diode normally permit A or B.
B.
B, correct. They will be permit current flow in only one direction. Okay, they're talking about barrier voltage. That means 0.7. Okay, you can see when this part here, the barrier right here, depletion, when it narrow, okay, then current electron can be moving. That's why you get the current flow, that the diode will be on. Okay, and in order for the silicon diode, they need at least 0.7 volt in order for electron enough power to move it. Okay, so that's why you can get 0.7 or 0.3. Okay, in here they can say about 0.6. That means they can be from 0.5 up to 0.7. That'd be fine. Okay, now the barrier voltage for silicon diode is about ABC.
A. A.
A. Correct. 0B, 0.6 volt. Not B, not A. They have to be 0.6,
B. Correct. B.
0.6 or 0.7. Okay, B, correct. Don't care about this thing here for your guy to read it. Okay. Diode is fully forward biased when applied voltage exceeds barrier voltage, there is no current flow.
A.
A. Easy question.
Yep.
A. Diode is reverse bias when A or B.
B.
A and B, actually.
A. There's no current flowing.
A is more accurate.
It's A.
They reverse bias when positive voltage applied to cathode and a negative applied to the anode. The answer will be A. That means VD cannot greater than 0.7. Okay. Now you can see you get a sine wave. Okay. This is a sine wave here. Okay, when they apply to the diode, and that is easy to recognize. When you get a positive, you turn on the diode, so the signal can coming out exactly the same thing here. However, when you get the negative, you turn off the diode. So that's why nothing. Okay, and keep going. So that's what we call a half-wave rectifier. Now, what that means for rectification? What that mean?
Voltage conversion.
Changing AC to DC.
Okay. Rectification means converting AC to DC. Okay, you can see the signal on the first here. That will be AC. And the second here, they will be DC. DC means direct current. Current flowing only one direction. Okay. On this output here, positive current flow this way. Zero, nothing, no current. However, when you get positive current, the same direction. So that's why, but they get a DC, okay? And they will be using a minor different name. We'll see next one. However, remember, rectify or rectification means converting AC to DC. You understand in your house, the outlet voltage will be AC, sideways. However, when they go into your microwave or heater or any machine, they must be converting into the DC. So that's why every time you're talking about diode, make sure you understand that means rectify or rectification, converting AC to DC. That's another one. And the name here, they given you the name. They call a pulsating DC current. or they can call a ripple. Okay, that's what they call a half-wave rectification. They only rectify positive only, not negative or the sideways. Okay. The thing is that they just give it to you, the input output, but we can more detail later on when we go to the circuitry, how they can do it. Okay, now, when a diode function at the halfway rectified, its output is a DC pulsating voltage when the AC input a reverse bias, forward bias, LB.
B.
B. Very good, B. Now, this one will be talking about the relation between the voltage and the current of the diode, like the other people student asked me last time. Okay, so basically, this stands for the current ID. Okay, and this will be stand for the voltage VD. So basically, the voltage when they go up to 0.5 volt or 0.6 volt or 0.7 volt and no more longer, they can increase anymore. No, they stop there. However, the current, they keep going. Okay, that means they allow the current to flow through the diode. But the voltage VD of the diode, they will be either 0.6 or 0.5 or 0.7 volt. They cannot be changed. Okay, so the diode will be working that way. And now this is a 0. Okay, when you get a negative in here, okay, they will be a reverse bias. Okay, and if you keep going more negative voltage, they break down in here. You cook the diode. Okay. Now, if you're reading on that thing, part of the diode DC characteristic curve that describe forward bias operation is the right side or the left side. Easy, right?
It's on the right side.
This right here, forward bias. This part here, reverse bias. Okay, so will be a right side, and this will be a left side. Let's see. Okay, we don't care. That's so easy. Okay, so this one you need to read it. Okay, let's see. Now, this is how you can test the diode. Okay, if you want to test the diode to see they're working or not, then you connect positive to anode, negative to cathode. You're supposed to get around 0.5, 0.6, 0.7 volt. Okay. And now, if you connect reverted, okay, normally, either way, you got testing by the resistance. If you connect a reverted, you get a very high resistance. The thing is open circuit. I only telling you, when you measure something, you connect positive, negative, the meter will be send the current out. Okay? And the current now in this one, they reverted. Current cannot slow it. So that's why resistance will be higher. Okay? So
approximately how many ohms, Mr. Pham? How high about?
How high about? It's hard to say. You have to connect it with the measured resistance. You connect positive, negative first, then you revert it. The ratio have to be very high, okay? Maybe about 1,000.
Okay.
Normally now, you don't have to do that. The thing on meter, they already get a symbol for measure, take out the diode. On this one in here, they say figure show ohm meter connect to test diode. The ohm meter indicate overload. The diode is good or bad?
Bad.
Bad. The thing is they connect positive anode, negative cathode, so the diode supposed to be on. Resistance have to be very small. Okay, so now I stop in here, okay? I want your guy to take the quiz. That review for what I already talked to you for today to see how many people can do it, okay? And this will be continuing on next Tuesday, not Monday. Monday we have a no class. Okay, so any question, anything?
Tuesday, no tech 2.
Oh, Tuesday, tech two, still tech two.
So next Wednesday?
Wednesday will be tech 1 and 2. Okay, so we will see you on next Wednesday. What I'm saying in here, try to read the handout over and over, marking whatever you not quite understand. Okay, nothing for free, right? You want to get the technician job, then you must be working a little harder. Okay, you understand everything we're talking about, you can be engineering for someday.
And Mr. Fan, before you turn this, so on this here, since you got an AC source, on the positive half cycle, it's forward bias, and the negative half cycle is reverse bias?
Exactly.
Okay, thank you.
Okay, now we're doing the quiz. For the quiz, you don't have to upload. You want it, you can do. Okay, but all of the quiz, you better keep track very good. That will be helping you. Okay.
Mr. Pham, you're not sharing screen.
Oh, sorry.
Okay, looks good.
Yeah, sorry.
Mr. Pham, when are you going over the answers? Today or
Today,
sometime?
today, quickly today.
Okay, thanks.
Just few minutes, then you can get everything. Okay, so now I will be let you guys know the key. Okay, that means the answer. You understand the quiz? Just try to very review what we're talking to you already. Okay, that means you see the question, you know right away what to do. Okay, that's number one. Okay, easy one. Number two. Okay, if you cannot take it quickly, then you can look into the web. Okay.
Mr. Pham, on that number 4, shouldn't it be 9.3 milliamp instead of 10?
Let's see. Number 4.
Yeah.
They want to calculate the R, right?
Yeah, current through the.
IR. Okay, you're correct. That's 9.3. Six 5-volt 70 milliamp. Okay, you see that when they measure the voltage on the circuit 1. So basically, if they working, diode is on, then they supposed to get 0.7 volt. When they say they get 25 volt, that will be telling you the diode will be open. So the voltage will be across the 10K. That means the voltage divider. That's why they get 25 volt. So the number 1 diode will be open. Number 2, they get 2.5 volt. Okay. So that diode will be what?
Short because it's as though it didn't exist. It's acting as though the diode wasn't even there at all.
If the diode off, okay, that means they will be open right here. Okay, open right here. So no current flow, they cannot get 2.5. That only telling you diode must be shorted. Okay, so that's a voltage divider here. That's why they get 5 volt times 47 divide 47 plus 47, you get 2.5 volt.
Hey, Mr. Pham, real quick, the minus part of the 5-volt battery is on the anode. So wouldn't that mean that it's the diode would be open?
No, they short it. If diode open, you measure right here, you cannot get 2.5.
Yeah.
They must be shorted.
No, Joe, I think Joseph is right. The battery is reverse biasing the diode.
Right.
So there's no current flowing in the circuit.
Right, I understand.
That's only if the diode's working.
However, what I'm saying is the meter they measure right here, they get 2.5. Then you cannot say diode open. If they open here, no way you can measure right here, 2.5.
Okay.
So that's why I said they will be shorted. Like
Sure. No, but wait, there's a positive voltage on the cathode, which means that you replace the diode.
Don't analyze on the circuitry, based on the meter. Meter measure 2.5. How come they get 2.5?
Because the diode shorted.
Yeah, that's what they want you to answer.
I see what you're saying now, Mr. Pham. The object of this particular circuit is to figure out why you get 2.5 volts there.
Right.
Okay. And since
based on the measure, tell me diode on, off, or normal. Don't telling me, you get negative diode, reverse bias, or who cares?
Oh, I see what you're saying now. Because if it was reverse bias, it would be open. So you wouldn't get any current flow.
But now what the point is, they said based on meter.
Okay, yeah. Based on the meter reading. Okay, number 3.
Open.
Circuit open, yes.
Open, yeah, 0.
Okay, this one I already gave her the answer right here.
What was the answer to that one? What?
I already given you the answer right here.
I don't see it.
No, they're here.
I mean.
This will be
12 volts.
That was a freebie.
Create 2K. Now 1K. 2K right here. Okay, I explain to you.
Can I ask a question real fast?
Now, for this circuitry, okay, if you want to calculate the V Thevenin, what can you do? Who still memorize that? If I want to calculate the V Thevenin,
You take off the low.
Get rid of the RL, yeah.
Yeah, very good. You take that out, right? Open circuitry here, right?
Right.
So, diode on or off?
Off, it's open.
Okay. Off. Then you're looking from here into the circuitry. The V Thevenin will be the voltage across 3K. So you're using voltage divider. 36 times 3 divide 6 plus 3. You get 12 volts. Okay? And if you want to calculate the R Thevenin, same thing. Remove the load. And you're supposed to get the current flow in.
I thought you had to short something.
Yeah.
Hey,
You have
Mr.
to
Pham,
short
I
circuit.
thought you had to short the battery.
I thought you had to take out the power, like the 36 volts here. I thought you had to take it out.
No,
You remove
no.
the load,
It's
right?
the open circuit
That will be
voltage
short,
and the short circuit current.
okay? That will be short right here. So you get the current flow from open go into here. One go to 6, one go to 3. So this the volt R Thevenin will be equal parallel between 6 and 3. So two resistor in parallel. 6 times 3 divide 6 plus 3. You get 2K.
Okay.
But that's for engineering, okay? Okay,
Hey, Mr. Pham, just one last thing on that one you just explained. So that last answer, you had to short out the battery and then take, wait a minute, you have to short out the battery and take out the load.
Right.
Okay, all right, okay. That's what I wanted to know.
Big one. See the answer right here. You can copy that.
Did you have a question earlier, Sarah?
Yeah, but I think it was answered. Thanks.
Okay.
Hey, Mr. Pham,
Yeah.
are we going to learn about Norton equivalent circuits as well as Thevenin equivalents?
Yeah, we don't need that. Like Thevenin or superposition, basically, we just let the guy know basic. But the thing is what happened at this time, no matter what you want, you can get a simulation program telling you everything why you have. However, if you go to the college or university, then you must be deal with that. In this program, we don't want to go to detail on that thing.
Got it.
I think we get only 1 year program. Up there, they get 2 years or more. But they only doing theory. So after the 2-year AS degree, they still don't know how to do the technician job. That's why one professor of the city college, they asking me to send the digital lab to them to see they can do it, but they cannot.
Really? That's interesting.
The thing is we doing based on the company. Whatever in the company they doing, we try to teach your guy. But CD, they don't know much about what's going on inside the company. What technicians supposed to do. So that's only the theory. I only go up to the CD college and see what they doing. I said, your guy doing look like behind 20 years. Everything they do by hand. Not like we're doing a left phone also. That cost too much money.
Mr. Pham, can you go over how you got IL here? I don't quite understand.
Okay, let's see. You get 2K and you get 1K here. Now, you're talking about IL, right?
Right.
IL, that means you get the voltage here.
Right, okay.
Let's see. First thing, they get only one current, right?
Mhm.
Okay, so they take the different voltage. That means 12 volt here.
Mhm.
Okay. 12 volt here, you have to minus 0.7 here.
Right. So then that will give you the voltage before going into the 1 kilo, the load.
That means the voltage for the circuitry here, right?
Right. But that's the
Then
voltage.
you divide by total resistance.
But that's the voltage. Okay.
Yeah, you got the VTH, which is the Thevenin voltage minus the 0.7, and then you divide by the RTH plus the load, because the Ohm's law, I is equal to V over R. So that's how you get the current there.
Okay. Yeah. Okay, I got it now. Okay, thank
And
you.
then he took the I times the 1K, and he got the load voltage.
Okay, if you want VL, IL times RL. Okay, that one already done, easy. Okay, VL will be VL. That means the VL here, right?
That was in question number 1. It's the same thing as question number 1.
Yeah, same thing. Okay, good luck. That's it.
All right. Good night. Happy New Year.
Thank you.
Happy New Year.
Good night.
Thank
Night.
you.
See you a week.
What year is it?
Okay, Fatoy.
2021.
No.
It's a
The year,
Good
New
night.
Year. It's the year of the what?
Vietnamese New Year.
Year of the Ox.
2022.
It's ox.